Hello everyone! I hope you're all doing great. The previous video was just a simple introduction to the training program. Today, this first video will be about the layer architecture, specifically, the layer architecture of the TCP/IP model. Why do we need to understand it? What we need to know is this: the RJ45 port, or any internet port in general, whether it's the cable or the RJ45 port itself, it's something universal, something that you can find everywhere in the world. And when we talk about something universal, there must be a standard that we all follow. We have to respect that standard to make sure we comply with the rules of the internet. This standard, there are several stages we must go through to understand it properly. To make these stages clear, we'll take an example. Parents want to send a letter to their son, and we'll see how each stage corresponds to a projection of the TCP/IP standard. If we say that we need to write a letter, the first thing we do is write that letter. So, to write the message, the first step is writing the message itself. This act of writing a message represents generating our data. At that moment, when we generate the data, everything that creates information in the world of communication is called the application layer. This is the application layer. In our example, it's the letter itself. But on the software side, it's the application that generates the data. It's the application that produces our data. For example, TIA portal generates data. Or web browsers like Firefox or Google Chrome also generate data. Or an application that we built ourselves using C# or Python, where we enter information for something like an EMS system or an ERP system. That's called the application layer. Anything we use to generate data is part of the application layer. As you can see here, it says the same thing. Role in TCP/IP provides the interface for communication and specifies the content of the data. So, the application layer is the one that generates the data we want to send. What we need to understand in this application layer is, when we write a letter, the first thing we write is dear, like dear friend, dear daughter, my dear, etc. We specify to whom we want to send this message. We're not talking about the address yet, we'll discuss that later. We're talking about the person who will receive and understand the message, the one who will interpret this information. Because if you're talking to your son, it's not the same as talking to your boss. So if someone else reads a message that wasn't meant for them, they won't understand it. It's exactly the same here. The same idea. Once we know who the message is meant for, and who exactly should receive it among all the people living at that address, that's where we talk about the protocol. Meaning, I want to send some data, but how will the receiver interpret that data? How will they process it? Will it be using TCP mode, or Internet IP, or maybe Modbus, or MQTT? What is the format of the data? That's also specified in the application layer. We'll see that later in more detail, including the port number and how the port numbering works. We'll see that in the transport layer. But for now, to understand better, let's stay with the application layer. When I want to send data, I must inform the receiver about the protocol used to encode the data, so they can decode it using the same protocol. So now we finished the application layer. The application has generated the data, for example, hello world. And I want to send it, for instance, from PC A to PC B, or from a PC to a server. The next step is the transport step. In the transport step, when we want to send a message, there are two methods. Let's limit them to just two. We have two ways. Either send it as a regular letter or as a registered one. If you send the letter normally, what are its advantages and disadvantages? The advantage is that it's faster. The disadvantage is that I don't get any return of information, meaning the letter isn't treated as something special. It just goes through the regular procedure that any letter goes through. But when I send it as a registered letter, it goes through a special process. That process takes a little more time. However, in return, I receive confirmation information, meaning that the person really received the letter and signed for it. They truly received it. It's the same thing in the transport layer. In transport, there are two procedures. There is UDP and TCP. When I send a normal message, that's UDP. I don't know if the message arrived or not, or if the person received it or not. But with TCP, I send the message and get a return confirmation that the person received it. It's the same thing for TCP. I send the data and receive an acknowledgement for it. But for UDP, I send the data, and I don't receive any return confirmation. So, what are the advantages and disadvantages of each? With UDP, I just send. I don't mind if the receiver misses a small part. For example, it's not a big deal if they don't receive a single piece of information. But with TCP, I must ensure the data is received by the receiver. If they don't receive it, I have to resend it again and again, like the postman going back until he finds the person and hands it over. Then the person signs that they have received it, and only then do I get the confirmation. So in this transport layer, it's all about the method of how we send the letter, whether we get a confirmation or not. And another thing, let's suppose I have a message with 100 pages. Can I put all 100 pages in one envelope? Of course not. So I'll take the generated data, the application-generated data, and in the transport layer, in the second procedure, we take the data and divide it. We say, 100 pages can't go into one envelope. We start dividing our data. So we send 100 messages, each containing 1 page, or 2 pages per message, or maybe 3 depending on the situation, depending on the maximum the envelope can hold. That's the maximum size the envelope can take. The same thing happens in transport. For transport, there's a maximum length that a packet can take. If it exceeds that, we start dividing based on that maximum length. Same thing. When we divide the data, there's a problem that can occur. For example, if I divide the 100 messages and send each page in a separate envelope, that means I'll send 100 letters. A problem can happen when the receiver gets the letters. They won't know which one is first and which one is second. And can I guarantee 100% that they'll receive them in order? I don't know. So the thing that exists in the transport layer, when we talk about segmentation, we're talking about segmentation dividing the data. I must identify each one of them, meaning the first message must be marked as message 1, then message 2, message 3, and so on, so that the receiver understands that there's an order. This is the first. This is the second. For example, if I receive the 5th before the 4th, I'll wait for the 4th before continuing. After that, I'll gather all 100 pages or data together and then start reading. Then I'll say, good, now the data makes sense. It's the same in the networking domain. If you want to send a 1 GB file, it won't go as 1 GB at once. It's divided and sent piece by piece, depending on the maximum length of each packet. That's for transport. So we've seen both the application layer and the transport layer. We now understand what each one does. Now we will see the next procedure. What happens after that? Now I've generated the data, divided it, and numbered it. I've decided whether I want a return acknowledgement or not. What is the next step that I go through? It's the internet layer. This internet layer. When I take my letter, I write the address on it. I give the destination address of the recipient I want. This address, I write the destination address, and I also write my own address, meaning the source address and the destination address. Same thing. In this internet layer, we write the source IP address and the destination IP address. Why? When I send the letter, the post office receives it. They'll know the address I want to send the letter to, and they'll also know which department should handle this delivery. Which department exactly? Is it the aviation department, or maybe the maritime department? We need to know which department it should go to. After that, when the letter reaches the city where the recipient lives, it will be handed over to the postal workers operating in that local area. What do we understand here? That the address guides the path the item should take. The same principle applies to networks. I want to send information, and the devices between me and the receiver need to know what to do with that data. What should they do with it? Should it be routed? Should it be forwarded? Meaning, does it need the internet or not? Am I sending it within a local network, or does it need to go to an external network? For example, if I want to access Google, I'll need the internet. But if I want to access my home routers page, I won't need the internet for that. The same concept applies. Why? Because of the IP address or address information assigned to the data. The equipment knows what to do with this data, whether to route it or not, whether to send it inside the intranet, or whether it needs to go outside to the internet. What devices are in between? Is there a router? Or maybe just a switch? What exactly should be done? This is the internet layer. This is where addressing comes into play. It gives us the routing path. If routing is required, we can determine the destination. At the same time, when the receiver gets the message, they know who sent it. That's why we also write the source address, so that if we want to reply, we can answer to the same address. And for example, if the post office can't find the recipient or the destination, they'll know the address to return the letter to. Meaning, if the destination is unreachable or doesn't exist, you must always include both the sender's and receiver's addresses. This way, information exchange remains possible, and we can also determine the route, the best path to take, so the message can be delivered. So that's the internet layer. That's what it contains. Now we move on to the network access layer. This network access layer, or the link layer, is also very important because it's the final layer. It's when the letter reaches the mailbox. Now, when the message arrives, it reaches the house, the address of the house, but it doesn't yet reach the person themselves, the actual intended person. For example, when you go to open your mailbox at home, you might find a letter addressed to your father. You say, "This one is for Dad, I'll give it to him." So it goes to the specific intended person, but the IP address only provides the general address. It tells us, for example, here's the house, or here's the university dormitory. But does it reach the person directly? No, it does not. That's where the link layer comes in. It provides that final layer that delivers the information or data to the exact device that needs it. This is the part where we use the MAC address. We'll see this in detail later in a lesson about MAC and SAP. It helps us understand why we use MAC and why we use IP. The IP gives us the address of the house, but the MAC gives us the address of the specific device we want to send the data to. When you make a request to Google, for example, when you type Google to open the page, Google doesn't know your internet directly. It doesn't know which computer sent the request. It only knows the IP address of your router. So when the router receives data from Google, it says, this one is for that person, and that one is for another. This one is for the computer, this one for the phone, this one for this, and that one for that. In this part, the link layer, it gives us the addressing part, the physical addressing, meaning the exact address of the device we're sending to. And what else does it do? It also handles the conversion of our data from what's in the virtual environment, not literally virtual, but from the processor and memory, to get the data out to the physical layer, which provides the electrical signals, the 0s and 1s of bits, that come out whether through Wi-Fi, Bluetooth, Ethernet, or radio frequency, anything related to physical transmission. So, in the end, we convert the data into electrical signals to send them out, or into fiber optic signals, or into radio frequencies. That final stage, where we actually send the data, is what we call the physical layer in the OSI model. But in the TCP/IP model, Both are grouped together in the link layer. That's how the stages go. Let's summarize what we talked about. The first layer is the application layer, where we generate the data. Here I generated the data, and we specify the protocol. When we generate the data, we tell the other side who should read it so they can understand what the message contains. After that, we move to the transport layer. How do we want to send this information? Do we want reliable delivery or not? For example, during a WhatsApp call, when you don't hear something clearly, you ask the person to repeat. It's okay, it doesn't matter if every packet is delivered exactly. But in downloading, you must receive every packet of data for the file or app to work. Because if 3 or 4 packets are missing, the program won't function properly. Same idea. In calls, no problem. In video calls, no problem either. That's why we use UDP, it's fast. And even if some data is lost, it's fine, even if the image is a bit unclear. But when downloading, the PC must receive all the files to install your app. So we have the application layer, then the transport layer, and after that, the internet layer, which, as we said, handles addressing to know which department we send to and which postman delivers the message. Once the message reaches your house, we move to the link layer, which handles physical addressing, like the mailbox, and from the mailbox, it reaches you, the person who will understand that data packet. You decode it. You also handle the conversion from the data you generated after finishing it, to make your data come out as electrical signals, or frequency signals, or fiber signals. That's how it works. We'll see this in more detail later. In the next session, we'll review each layer again, but we'll look at it from the network side, meaning we'll see exactly what happens in each part and what we do there. We'll go over the same stages, but try to go deeper. That's it, brothers. I hope this helped you and finds you well. See you next time.